Reciprocal equation. In this video, we shall discuss the solution of a reciprocal equation of odd degree and second type. Let's rearrange the given equation and write it as. Here we have combined x7 with -1, 4x6 with -4x, 4x5 with -4x square, x4 with minus x cube. We further arrange it and write it as x7 minus 1 plus. Here we have taken 4x common from 4x minus 4x6 minus 4x, 4x square common from 4x5 minus 4x square, and x cube common from x4 minus x cube. Now we shall factorize x7 minus 1, x5 minus 1, x cube minus 1. For this, we shall make use of the formula x raised to power minus 1 is equal to x minus 1 into x raised to power n minus 1 plus x raised to power n minus 2 and so on up to 1. Note that in this formula, the variable x has power n, and in the second factor, the power will be reduced by 1 and then it will be gradually decreased by 1. Using this formula, we can write x7 minus 1 equal to x minus 1 into x raised to power 6. Here x has power 7, the power will be reduced by 1 in the first term of second factor, and then it will be reduced by 1 gradually. Similarly, x5 minus 1 can be factorized in this manner, and x cube minus 1 can be factorized in like this. We shall use these formulas in the above equation and write it as. Here x7 minus 1, x5 minus 1, x cube minus 1 has been replaced by their expanded forms. Now we shall take common x minus 1 from all terms of left hand side. After taking x minus 1, we are left with these two factors. Now we further simplify and write it as x minus 1 into this whole term. Now we shall combine like powers of x. Here is x raised to power 6, then x raised to power 5. Then we shall combine x raised to power 4. Then we shall combine x raised to power 3. Then we shall combine x raised to power 2. And then x raised to power 1, and then the term independent of x. So after simplification, we can write x minus 1 into x raised to power 6 plus 5x5 plus 9x4 plus 10x cube plus 9x square plus 5x plus 1. We can write it as x minus 1 is equal to 0, or x raised to power 6 plus 5x5 plus 9x4 plus 10x cube plus 9x square plus 5x plus 1 is equal to 0. From the first term, we can get x is equal to 1. The second factor, x raised to power 6 and so on, this is a reciprocal equation with even power. Now we can easily solve it. The maximum power of this equation is 6 and half of 6 is 3. We shall divide this equation by x raised to power 3. After dividing this equation by x raised to power 3, we get x raised to power 3 plus 5x square plus 9x plus 10 plus 9x plus 5 over x square plus 1 over x cube. We combine these specific terms, x cube with 1 over x cube, 5x square with 5 over x square, 9x with 9 over x. Now we take common and further simplify it and write it as x cube plus 1 over x cube plus 5 into x square plus 1 over x square plus 9 into x plus 1 over x plus 10. We shall call this equation as equation 1. Now we use the substitution and put x plus 1 over x is equal to z. Now we are to find the values of x square plus 1 over x square, x cube plus 1 over x cube. So we take care of this substitution and we get x plus 1 whole square, x plus 1 over x whole square is equal to z square. On simplification, we get x square plus 1 over x square is equal to z square minus 2. Likewise, we shall take cube of equation 2 and we get x cube plus 1 over x cube plus 1 over x cube plus 3 x into 1 over x into x plus 1 over x. A cube plus b cube plus 3ab into a plus b. Now x plus 1 over x is equal to z. This x will be cancelled by this x and we are left with x cube plus 1 over x cube plus 3z or z is equal to z cube, and it gives x cube plus 1 over x cube is equal to z cube minus 3. Now we shall replace these values in equation 1. Therefore equation 1 becomes, here we have replaced x cube plus 1 over x cube by z cube minus z, x square plus 1 over x square by z square minus 2, and x plus 1 over x by z. So the equation now can be arranged as and written as z cube plus 5z square plus 6z is equal to 0. We take z common and write it as z into z square plus 5z plus 6 is equal to 0. It gives z is equal to 0, or z square plus 5z plus 6 is equal to 0. Now we factorize this factor and get z square plus 2z plus 3z plus 6. Eventually it gives z plus 2 into z plus 3, and it gives z plus 2 is equal to 0, z plus 3 is equal to 0. So we have obtained the values z is equal to 0, z is equal to minus 2, z is equal to minus 3. Now we shall replace these values of z in equation 2 and solve one by one. First we put z is equal to 0 in equation 2 and get x plus 1 over x is equal to 0. Uh, on taking LCM, we get x square plus 1 over x is equal to 0. It gives x square plus 1 is equal to 0. And eventually we get x is equal to plus minus iota. Then we put z is equal to minus 2 into and get x plus 1 over x is equal to minus 2. We take LCM on left hand side, multiply this x with minus 2 and get x square plus 1 is equal to minus 2x. Transpose minus 2x towards left and we get x square plus 2x plus 1, which is the perfect square of x plus 1 whole square, and we get x is equal to minus 1 minus 1. As power is 2, therefore minus 1 will be written twice. Now we put z is equal to minus 3 in equation 2 and write it as x plus 1 over x is equal to minus 3. We take LCM on left hand side, multiply the term on right hand side by x and get x square plus 1 is equal to minus 3x, which gives x square plus 3x plus 1 is equal to 0. Now we shall use the quadratic formula. Here a is equal to 1, b is equal to 3, c is equal to 1. We apply the quadratic formula and replace the values of a, b and c. After simplification, we get x is equal to minus 3 plus minus square root of 5 over 2. Hence, the values of x are 1, minus 1, iota, and minus 3 plus minus square root of 5 over 2. Here we have 7 roots. As the original equation has x raised to power 7, therefore the number of roots must be 7, and we have obtained the roots of the given reciprocal equation of odd degree and second type.